Actually, you know very well about the different types of motions. One is translatory motion, oscillatory motion, circular motion, and rotating motion like this. Now, I want to explain about the combination of both motions, that is simply called as rolling motion. Now, let us today's topic, so I have to go to that. Rolling motion. In this, we will put the two subtopics. Rolling without sliding and rolling with sliding. Rolling without sliding rolling with sliding. Now, so what is mean the rolling motion before on that? Is anybody observed that going on a bike or a bicycle? Can you say that what is the motion of the bicycle? Translating, rotating, or circular, or oscillating? Can you say that? Motion of the bicycle. Translated. Suppose we take the whole bicycle, is it translated? But once you observe the wheel of bicycle, what's happening? The wheel is rotatory and also it is moving forward direction. So, this is a combination of translatory motion and rotatory motion. So that is called as rolling motion. The rolling motion is nothing but, the rolling motion is simply write like this, combination of rotational motion plus translational motion. So that is the rolling motion is a combination of rotational motion and translation motion. Let us go to the simple example of on the ground. Putting that, we take a circular object or a rounded object, whatever that, like a disc or ring or a cylinder like this. Let us just once we will go to that rotatory motion. What is the rotatory motion? Once observe this. Suppose I go like this. Then what's happening? With my axis we can take that. So that is this revolve around this individual. Suppose we take that. Suppose we imagine one point here. Imagine one point here. When revolving this, what's happening? From about the fixed axis, this point should be completed in circular motion. Am I right? That means the rotatory motion means the body should be complete. Means rotates about its own axis. Now, once after this body, its rotatory motion means if you moving with the angular velocity omega c. Omega c means angular velocity with respect to center of mass. Now, you can go to that when a body is in a circular motion, then you can take the initial velocities. So this is the radius r. The velocity of the particle at this point, what's happening? Now this is along the tangential. You can go to that. The body is in a circular motion at any point, the velocity always along the tangential. Now here, at this point, what's happening? It is rotating like this. Once after this is rotating like this. Now, this is velocity. Now this is velocity with respect to this. Now this is r omega c. Now this is r omega c. That means the body is in a rotatory motion. At any point, the velocity always tangential. Good simple logic. Rotating, we take a thread, stone with like the thread. We rotate it like this. At any point, we leave it. What's happening? The particle follows the tangential path. Now, at this point, what the velocity is? This is r omega c. Suppose if we take it at this point, this velocity is r omega c. Now, what you are observing here? When the body is rotating like this, with the velocity omega c, the angular velocity omega c, at any point, the velocity is tangential. That should be equals to the product of radius of body and the angular velocity. This is the value of this. Now this motion is called as rotational motion. Now plus, suppose the same wheel is on the ground, same wheel is center, if it is moving translated velocity Vc, is translated motion. Let us observe the velocity at any point. This point. Now this is velocity is Vc. Let us take this point, this velocity is Vc. We take this point, velocity is Vc. If we are taking this point, velocity is Vc. That means this is what's happening. The body is moving. Each particle is the same velocity, that is equal to the velocity of center of mass. Now this is called as translated motion. If you combine the both, that is called as rolling motion. Now what's happening? Let's observe here. Now what is observed here? What is observed the point here? Suppose this point A, this is A, now this is B, now this is B, now this is C, now this is C, now this is D, here this is D. Suppose if you combine both, this is the body is in rotated motion, the body is in translated motion. Now once observe the wheel of the bicycle, what's happening? It is going for, that is combination of both rotated motion and also translated motion. Now once observe this point. So these two are vectors, these are omegas and these both in the same direction. Both in the same direction. So what's happening in the velocity here? Here the velocity is Vc plus r omega c. Here at bottom point, what's the velocity? This is Vc, this direction, rightward, r omega c leftward. If you combine the both, then what is the velocity at this point here? Vc minus r omega c. Now at this point, we combine this c. Now at here this is r omega c. This is velocity of center of mass according to vectors. So what's happening? This is the resultant velocity. Now this is the resultant velocity. Now is anyone observe this important point? Well, the body moving at both translatory and rotatory. Now this is called as rolling motion. This is very, very important point. The body in a rolling motion, at the topmost point, the velocity is greater than the bottom point. Am I right? So that is the reason we are observing the wheel, cycle wheel. At the top, that is called sticks. That is called as the spokes will be invisible. We compare to the bottom. Why? Because the bottom point the velocity is more. At the top, velocity is less. Sorry, at the top velocity is more. At the bottom, velocity is less. So that is the reason we compare the position of the spokes of the cycle wheel. If you are moving, the bicycle is moving fastly, then it should be invisible to invisible means that should be blurred. So where it will be easy to visible, the bottom or top spokes very easy to visible. The bicycle is moving, the spokes will be there. So at the topmost velocity will be Vc plus r omega c. This velocity is more. That means when the body is rotating, means rolling motion, the velocity of the topmost point is greater than the velocity of the bottommost point. So if the velocity is less, the velocity is more. So that the reason the cycle is rotating. We observe, if anybody observe just the spokes of the at the top is above the surface, above the center of this, it should be blurred. That means we can't distinguish the spokes if we are moving the current means bicycle moving the common velocity. Suppose at the bottom part the velocity is less, the body is rolling motion, so it should be visible. If you anybody observe in your daily life, if you go through that. So this is the combination of rotating motion and translated motion. So rotating motion and translated motion is nothing but rotating motion means if the particle is revolving around about its own axis, body is revolving about its own axis, this is some angular velocity. At any point, the velocity always tangential to that. So the velocity at any point that velocity is tangential, that should be equals to r omega c. Now this is rotated motion. If in the case of a translated motion, the body is moving with the common velocity over. That means translated motion is all particles should move in the common velocity in the body. Now we combine the both, rotational motion and translating motion. That is called as rolling motion. When observing the rolling motion, the different particles have different velocities, but when observing this, the topmost point, the velocity is higher than the bottommost point. So this is about the rolling motion. Let us think about that rolling without sliding. Okay. What's that? Rolling without sliding. Now let us discuss about rolling without sliding. So what is the rolling without sliding? Let us observe this. We take that this is a ground. Now we take any rounded object. Now this is a rolling body which is the combination of both rotating motion and also translating motion. So omega c is angular velocity, because omega c is angular velocity about its center of mass. Omega c is about its center of mass. This is linear velocity of center of mass. Now it has both combination of rotating motion and translating motion. Now you can observe this at any point. This is the ground like that. Now just after this bottom point which is contacting the surface. This bottom point is very important here. So now once after this when it is contacting, the point on the body is taken as Q1. The point on the surface is taken as Q2. That means when the body is rolling on the surface, if the point Q1 is point of contact with ground, this is point of contact of body with ground. Now the Q2 is point of contact of ground with body. That is the 2 points. One is the point of contact with the body, and the one is same. Both are same. Suppose you take this and contact at this one point on this surface, one point on this surface. I take the 2 points, Q1 and Q2. Now we already discussed in the previous case when the body is in rolling motion, pure rolling. What's happening here? This is center of mass, this is velocities. At the topmost point velocity is Vc plus R omega c, and the bottommost point Vc, feel like this is Vc, now this is R omega c. Now if it is moving like this, Vc minus R omega c. Why? Because both are moving in opposite directions. Here both are in the same direction, we already discussed it. Now at the bottommost point Vq1 is equals to velocity of Q1. Velocity Vq1 means velocity of the body at the Q1. So velocity of the point Q1. This gives us velocity of point Q1. So that should be equal to what's happening? Vc plus R omega c. Now suppose Vq2 is equal to V. So that is velocity of point Q2. Now in the case of a rolling without sliding, come to this point, sir. Rolling without sliding means the relative velocity of this means when it is once after the 2 cases. So once, now this is here, this like this. Now once after this is. Now once after this is what's happening? The body is rolling. Am I right? If you can observe at any instant the point of contact of the skin and this body, at any instant the point of contact will be at the state of rest. That means the relative velocity of Q1 with respect to Q2 equals to 0. That means this is what this gives us. The point of contact always rest with respect to ground or surface of contact. That means this Q2 is taken on the surface, point on the surface, Q1 is taken on the surface of the body with respect to each other, always at rest. So take that, this is from ground. Can you say what is VQ2? From this data, what is VQ2? 0. Why? Because the take as ground. Now, what is VQ1? VQ1 take this point velocity. In this case, this omega, this is VC minus R omega C. Now that should be VC minus R omega C. So what's happening here? When the tubes without sliding, then what's the point of contact always rest. That means this Q1 is rest with respect to Q2. Now VQ2, VQ1 Q2 equals to VQ1 minus VQ2 because of relative velocity. So it is always at 0. Now VQ1 is what? VC minus R omega C minus VQ is 0. Why? Because I take the surface is ground. So from this data, what you are observing here, VC minus R omega C equals to 0. From this, VC equals to R omega C. Now what is observing here? When the body is rolling on the ground, if the velocity of the center of mass and R omega C, they both are same. That means if the VC equals to R omega C and ground, then that is said to be there is no sliding. That is called as pure rolling. That is called as pure rolling. So that's very simple. Once observe this is. Suppose if it is falling individually, that is observe this is pure rolling. Just observe this is pure rolling. Suppose can you say that what is the difference between these? If it is individually rotating, otherwise this is freely rotating. Once observe this is freely rotating like this, rolling. Now what here what's happening? This is inside here the rolling takes place. But then due to the friction between this, just observe this is 2. Just can you observe this between water is there? Okay. Can you observe this is here this is. Now in case of pure rolling, once observe this is, can you go to diagrammatically? Pure rolling, if you observe this is, now this is center. If it is rotating like this, can you observe this is, just observe this. When rotating like this, now the body is about moving forwards. But in the case of A, this is without sliding. In the case of sliding place, what's happening? At an instant, this should be rotated at an instant. But in this case, what's happening? When moving the weight, it should be rotated. This is when moving the weight is rotated. But in the second case, what's happening? Individually it is rotated. This is by sliding. With this sliding. So mathematically, one important point is when the body is sliding without slide, that is called as a pure rolling. This is called as pure rolling. In this case, the point of contact, just after these 2 points, the point of contact of the body and the point of contact of the ground, both surfaces, the relative velocity always equals to 0. So always relative velocity 0 means what? With respect to each other is at rest. That's it. The point of contact always rest with respect to ground, a surface of contact. It is called as pure rolling. Let us go to a small example. Suppose a disc of radius 5 cm is moving with velocity 4 meters per second. It is rolling. It's rolling with velocity omega. That means a disc of radius 5 cm. It is rolling on the ground. This is a ground. It is moving with velocity 4 meters per second. Here the important point: if disc is pure rolling, so pure rolling means that is no slipping or sliding. Then what is the angular velocity? Now what this is? Here there is no sliding, pure rolling. In the case of a pure rolling, what is the condition on the ground? That's important. On the ground, what the condition is? The center of mass velocity must be equals to product of r omega c. Am I right? Now what is the answer here? So for the pure rolling on the ground, so Vc equals to r omega c. Here the ground, we take the ground. So Vc equal to what? 4. R was 5 cm. 5 cm is 10 power minus 2. You want omega. Then omega equals to 4 by 5 into 10 power minus 2. That equals to 4 into 100 by 5. 20. The answer is 80 radians per second. So this is the simple. Here what it is? It is a ground. Suppose you take the list of a ground, a moving body. That's I said here. The point of contact always rest with respect to ground or surface of contact. That means the body is rolling on here. We take the 2 points, one point on the body, one point on the surface. With respect to each other, always at rest. That is said to be pure rolling. I got the point here. Now, let's go to one example. Let's go to one more example. Are you clear this? So pure rolling means, so we take the ground, on the ground. The point, very basic important point for the pure rolling is the point of contact on the rolling body with the surface. The relative position is always at rest. That means the relative velocity always equals to 0. That means, why take the dq is 0 here? Why take the dq is 0? Qt is point on the ground. So ground is at rest. So that is dq is equal to 0. So here vq1 is point on the body. When the body is holding point on this point, what is the velocity here at this point? Here at this is Vc is this direction. R omega c is in opposite. Vc is R omega c. So at the point velocity Vc minus R omega c. Now what's happening to them? The pure the point always at rest. So rest means relative velocity equals 0. So relative velocity is Vq1 minus Vq2. So Vq1 equals to Vc minus R omega c minus 0. Why? Because Vq2 is 0. That equals to 0. So here what are taking here? The already V not equal to 0. This is the condition. Vq2 equal to 0. The condition is Vc equal to R omega c. Have you got the point here? So I got one more example to this. Suppose on the platform is moving with velocity of 5 meters per second. On this one rolling disc, you take that on platform. This is center of the rolling disc. The rolling disc is moving with velocity of 2 meters per second. With radius is 4 centimeter. It is rolling. That means, another question is, a disc of radius 4 centimeter is pure rolling. That's important point. Pure rolling on a platform which is moving at 5 meters per second. I got the point here. Now, if it is rotating with omega this direction. Now, what is omega will be? Now, the same concept. It is pure rolling. So, pure rolling is the point of contact always at rest. So, let us take the 2 points here. One is point Q1. This is on the body. At the same time, one point is taken as Q2 on the platform. You got the point here. Now, what is the Q1 velocity? Tell me anybody. Vq1 is how much? Vq1. Now, at this point, Q1. So, Vq1 means this is Vc. system will move forward direction. So VQ1 equal to how much? VQ1 is how much? VC minus R omega C. Then VC is 2 minus R is how much? 4 centimeters. So 4 into 10 power minus 2 meters. We don't know about omega C. This is first one. Next, the same Q1 is connected to Q2. So last of Q2. Tell me what is the last of Q2? Why? Because Q2 is on the platform. Alright? So Q2 means what is the last of Q2 is? 5 meters per second. Now what is the pure rolling? Let's come to the point. What is the pure rolling? The relative velocity with respect to each other always equals to 0. That means the 2 points, one point on the body, one point on the surface. For the pure rolling, the relative velocity equal to 0. So what's happening? For the pure rolling, velocity of the Q1 with respect to Q2 equals to 0. That means VQ1 minus VQ2 equal to, the both are the same. If you take that, then what's happening? 2 minus 4 into 10 power minus 2 omega C minus 5 equals to 0. So we can go to that. What will get the answer here? So 2 minus 0.04 omega C equals to 5. Minus 5 will be this side. So now minus 0.04 omega C equals to minus 3. So minus minus cancel. Now omega C equals to 3 by 0.04. So that approximately 3 into 100 by 4, 25. That equals to 75 radians per second.
Plus omega negative. Omega will come negative.
So this is plus 3, omega minus. So omega negative means what? What we take the direction is clockwise direction taken that. So our direction is negative means what is the actual answer here? This is wrong. So what is that is anti-clockwise direction. I got the point here. So this is about the pure rolling. So what the main important part of the pure rolling is the point of contact, which is contact with surface, always at rest with respect to surface. So in the first case, why I take the VC equal to R omega C? I take this in the ground. I got the point here. So next case, we can take that rolling with sliding. So rolling without sliding is the concept here. I have understood the point here. I got that rolling without sliding. So here one second repeat the point. What is the rolling motion is? Rolling motion is nothing but the combination of both translatory and rotatory motion. In this case, we already discussed when the body is rolling motion, the topmost point has more velocity rotating like this, clockwise direction. The topmost velocity is greater than the bottommost point. So that means in the case of translate rolling motion, the different particles have different velocities. Am I right or not? But in the case of translated motion, all particles have same motion. But in the rolling motion is combination of translatory and rotatory motion. Now, in this case, we discuss pure rolling without sliding. So, without sliding means the point of contact which is always at rest. Now, let us go to that rolling with sliding. Okay, next class we will discuss about rolling with sliding. So, all of you this point here. So, okay.
రావట్లేదు మొక్కలో పెట్టండి మీరు ఇక్కడ వస్తే ఎలా ఉంటుంది చెప్పండి
చెప్పండి అవుతుంది.
లేదు క్లారిటీ చేశాను అసలు
సార్ నేను కనమాట్లేదు నాకు కనమాటే ఆఫ్ చేసేయండి సార్. మరి సినిమా యాక్షన్ అవుతాను
మరీ అందుకే హైలైట్ ఏంటంటే ఇది మీరు ఇప్పుడు వేళ కవర్ చేసామా ఇందాక మీరు ఇక్కడ రాసేది కదా చదివి రెండు కదా సార్ అక్కడ వరకు యూజ్ చేయండి బోర్డు మీ బోర్డు అంతవరకే ఉంది అక్కడ మీరు చేసి చూపించేంత టైం వస్తుంది
सेकेंड है ये
సెకండ్